Hey, welcome to part 2. This is the second page of the review guide we are doing. Luckily, this page is actually going to go pretty quick. These are mostly you know it or you don't kind of questions. So let's get started. It says, if a factor of a polynomial is x minus 5, what is one of the roots of the polynomial? It's as simple as setting it equal to 0, add 5 to both sides, and the answer is 5. Done. If a factor is 3x minus 1, what's one of the zeros? Important thing to note is like these words they're using, roots, zeros, they're the same thing. Roots and zeros are the same things. It could also say solutions. No matter what, it's still just saying, hey, set them equal to 0 and solve for x. So you get 3x equals 1 and you divide by 3. So a third. There you go. That's the answer to 6. Number 7, if a root of polynomial is negative 3i, what are 2 of its factors? So this one's a little bit different. It's telling you it wants 2 roots, and the only reason we're able to do this is because this is an I problem. With I and square root problems, there's always 2 things you can do. Remember that I is the square root of negative 1, so technically they're both root problems. And what happens is when you have any roots, they are always, even if it's not written, but they are always plus or minus problems. So even though it doesn't write positive 3i, it is a positive 3i. That's because reasons, we went over in class. Basically, if you remember, in a quadratic formula, it has be plus or minus the square root of stuff over 2a. Anytime you have a root, it always has a plus or minus in front. So whether it's an imaginary like an I or a real one like 3, it'll always have that plus or minus in front. So how does this help us? If a root is 3i, what are its factors? That's the thing where it's like you switch the sign. So to start with, if this is minus 3i, then I would write x plus 3i. But for the other one that's plus, I would write x minus 3i. And that's 2 of its factors right there. So that's the answer. Same thing down here. If an x-intercept is at square root of 3, what is another 0? Same concept. Since it's a root, it's a plus or minus in front, even though it doesn't write it. So the answer is negative root 3. Done. And which of the following shows a function's 0? The big thing to note here is that means it should be equal to 0. It means if you plug in a number, you get 0. It doesn't matter what number you're plugging in, but the answer is 0. That's what a function 0 is. So here, if you plug in 3, you get 0, which is what we wanted. If you plug in 0, you get negative 2. That's not what we wanted. We want it to be equal to 0. We want it to be equal to 0. We want it to be equal to 0. So the only one that matches this is the first one, because you get 0 as your answer. Lastly, dividing. I'm going to do synthetic division because it's easier. The first thing I'm going to do is take this, set it equal to 0. That way we get x equals 3. And that 3 is going to be on the the left side of our big L. And we are going to start writing the coefficients down here. But before we do that, we have to double check to see if there's any missing exponents. So let's see, are there any missing exponents? The highest exponent is 4, so we should see an x4, an x3, an x2, an x1, and an x0. So here we go. I see an x to the 4th, an x to the 3rd. Oops, there is no x to the 3rd. That means between these two, I'm going to have to put a 0. So 4, 3 is missing, 2, 1, 0. So it looks like 3 is the only one missing. And now we're going to write down all the coefficients. So this just has a 1 in front. So 1, 0, down to 2, over to negative 5, over to negative 30. So 1, 0, 2, negative 5, negative 30. It's the numbers in front. The 3 is missing, so we put a 0. It's called a placeholder. What we do now is we drop down that 1. and we will multiply. We will multiply, put it here, and add. We'll multiply, we'll add, we'll multiply, we'll add, we'll multiply, we'll add, like that. So I recommend trying it, since this is just a review. Pause it, give it a shot, and then we'll unpause it and look at it. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. 9 plus 2 is 11. 3 times 11 is 33. These being added is 28. These being multiplied, 84. Yeah, I knew that right off the top of my head, which gives me 54 when I add them. Yeah. So our answer, first of all, this is the remainder. So it's going to end with plus 54 over x minus 3, because that's what we're dividing by. This number is going to be a regular number. This one is going to be an x squared, x to the third. So 28, 11x, 3x squared, and then x to the third. Sorry, you can't see that. There we go. Boom, 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 boom. That is the answer to the question when you divide. Looks like we still got some time left, so let's go do another dividing problem, and we'll call it after this. Excuse me. Okay, in this one, x plus 1 equals 0, so you get -1. So -1 will be on the outside. Check the exponents. 3, 2, 1, 0. Everything's there. So 2, -4, -20, -8. Once again, I'd suggest pausing it, seeing if you can figure it out. Here we go. Drop the 2, multiply, and add, multiply, add, multiply, add, and done. Rope this off as the remainder. So this is the regular number, this is the x, this is the x squared. So 2x squared minus 6x minus 14 plus the remainder of 6 over x plus 1. Okay, we'll end it there and we'll come back with the next part afterwards. Thanks for sticking with it. Bye.